This is a question relating to the Hess's law of constant heat summation. In this question, heat of combustion of acetic acid is minus 875, heat of combustion of carbon is minus 393, heat of combustion of hydrogen is minus 285, and we have to find the heat of formation of water. At first, we will construct the equations. Acid combustion means burning of substance in presence of oxygen. So acetic acid is burned in presence of oxygen that forms carbon dioxide and water. And delta H in this case is minus 875 kilojoule per mole. And in order to balance this, as 1 mole of substance is burned, we will place 1 before that. 2 carbon atoms are there, so multiplied by the 2. 3 and 1, 4. 4 hydrogen atoms are present. 2 to 4 into 6. 6 oxygen atoms are present, multiplied with the 2. As carbon is burned in presence of oxygen, that forms carbon dioxide. Delta H is equal to minus 393.5 kilojoule per mole. Hydrogen is burned in presence of oxygen, that forms water, and delta H is equal to minus 285.8 kilojoule per mole. And as 1 mole of acetic acid is formed, heat of formation is the formation of 1 mole of substance from its elements in the standard state. Elements of acetic acid are carbon, hydrogen, and oxygen. In the standard state, carbon exists in the form of C, hydrogen H2, oxygen O2. There are 2 carbon atoms, 3 and 1, 4 hydrogen atoms, and there are 2 oxygen atoms. So heat of formation we have to find out in this question. In order to solve this question, this is the required equation, and we use all these 3 equations in order to construct this equation. Acetic acid is on the product side, and this equation acetic acid is on the reactant side. So in order to make it on the product side, we will reverse equation 1. As equation 1 is reversed, we will write products on the reactant side and reactants on the product side. And as we are reversing this equation 1, delta H will also be reversed. Over there was this was of negative sign, so we will represent it with the positive sign, plus 875 kilojoule per mole. Remaining in the required equation, carbon is on the reactant side. In given equation, this is also on the reactant side, so this equation will remain as such. Hydrogen is on the reactant side. In given equation, that is also on the reactant side, so this will also remain as such. And its heat values will also remain as such. Delta H2 is equal to minus 393.5 kilojoule per mole, and this is delta H3 is equal to minus 285.8 kilojoule per mole. Then we will add to get the final equation. In order to add this, carbon dioxide is on the reactant side and on the product side as well, so we will cancel it, but there are 2 moles on the reactant side and 1 mole on the product side. In order to cancel it, we will multiply it with the 2. These 2 carbon dioxide will be cancelled with this 2 carbon dioxide, and this heat value will also be multiplied by 2. There are 2 water molecules on the reactant side, 1 on the product side. We will also multiply it with the 2 in order to cancel water. So these water molecules will be cancelled with the water. So this delta H will also be multiplied by the 2. And the remaining equation that we get is 2 carbon 2 hydrogen, 2 in 1, there are 3 O2 that forms, sorry, this O2 can also be cancelled with this O2, so there will be 1 O2 remaining that forms acetic acid CH3COOH, and this delta H, if we add it, delta H will be equal to delta H1 plus delta H2 plus delta H3. If we multiply these values, we get answer is equal to minus 483.6 kilojoule per mole.